Welcome to NASA STEM EPDC Quick Bits Big Ideas in Science Content. NASA STEM Engagement and Educator Professional Development Collaborative provides NASA resources and STEM strategies for STEM engagement. In this series, we intend to reach educators, parents, and caregivers to quickly explain a specific big idea in STEM. We will introduce a NASA example of how this idea is applied in the real world, and finally, we will demonstrate step-by-step how to lead this activity at home or in the classroom with your students. You might invite your students to watch with you at that time. We invite you to join us as we learn more from our specialists. Let's get started.
Hello, my name is Sara Torres, and I am an education specialist at Ames Research Center in California. The big idea in this quick bit video is that the sun, our closest star and center of our solar system, produces heat and light for the Earth. We will begin by learning 10 facts about our sun. Then, we will watch a NASA video and hear about the relationship between our sun and the Earth. Finally, we'll learn more about the two types of energy that Earth receives from the sun. One that allows us to see, and one that we can't see, but we can certainly feel the effects if we stay out in the sun for too long without protecting ourselves. Today, I will be sharing an activity titled Make Handprint Art using ultraviolet light that is shared on the NASA Space Place website. This activity demonstrates what happens when we stay out in the sun too long without protecting our skin. NASA Space Place site is produced for NASA Science Mission Directorate by the NASA Space Place team at NASA's Jet Propulsion Laboratory. This site is an award-winning Space Place website that engages upper elementary age children in space and earth science through interactive games, hands-on activities, informative articles, and engaging short videos. Now's a great time to invite your student to learn about our sun, the energy our sun produces, and its effects of energy on our Earth and in space. Let's review the top 10 facts we know about the sun. First, the sun is a star. This makes it extremely important for life on Earth. The sun provides us with energy which brings life on our planet. It defines the seasons, the harvests, and even the sleep patterns of all living creatures on Earth. Next, the sun is the closest star to our planet. Imagine two cars on the road during the night with their headlights on. One car is closer to you and the other one is far away. Which headlights would seem brighter and bigger? That explains why we see the sun so big and bright. It is simply the nearest star to the Earth. Another fact to remember is that the Earth orbits around the sun. Also, the sun is way bigger than the Earth. In fact, its radius is 109 times bigger than the radius of the Earth. For those of you who are curious, the sun's radius is 696,000 kilometers, and the Earth's radius is 6,376 kilometers. Another fact to remember is that the sun is hot. The sun's average surface temperature is 5,007 degrees Celsius. Compare that to the Earth's average temperature, which is 20 degrees Celsius. How far is the Earth away from the sun? Well, the sun is 150 million kilometers. That's 93 million miles away from the Earth. How old is the sun? Can you imagine? The sun is 4.5 billion years old. The sun is made of gas. The sun rotates on its axis once every 26 days. The sun changes. That means that no matter when or where we look at the sun, we will always see something interesting. Scientists observe these changes by watching the sunspots. They increase and decrease on a regular cycle of about 10.8 years. I want to share a NASA video with you that tells us about the relationship between the sun and the Earth. But before we get into the video, let's review key vocabulary to help us better understand. Plasma is heated gases. Core is the center of the sun. Photosphere is a layer of the sun that is light that we see. Corona is the sun's outer atmosphere. Solar wind is energy being sent as charged particles. Magnetosphere is a protective outer layer, or the magnetic atmosphere that surrounds our planet. Solar flare are powerful explosions on the sun. Coronal mass ejections is when sun throws highly energetic particles out into space. Auroras are light displays near the poles of the Earth. Infrared radiation is energy from the sun we feel as heat. Visible light allows us to see objects. Ultraviolet light, or UV light, we can't see but feel its effects. Now, let's watch the NASA video to learn more.
Living with a local star can be a little bit of a hassle. But once you get a better understanding of your relationship, you can become a lot more than just fair weather friends. It's important to have an understanding of the relationship between the sun and the earth, because it's a relationship that directly affects human life. The sun is an important part of our lives. We have fun playing or relaxing in its light. It keeps us warm and helps grow food. But the sun itself is not a peaceful place. The sun is a star that is incredibly powerful. Space weather begins here. Why is space weather important to us folks here on Earth? Well, we all know how weather affects us on Earth. If it's raining, grab an umbrella. If it's cold outside, grab a jacket. But space weather also has an important impact on our lives. So where does it all begin? Let's get back to the sun. The sun may be a big ball of plasma or heated gases, but it still has distinct layers. Under the surface of the sun lies a restless world of unbelievable power. Huge amounts of energy are released that bubble and boil to the surface. This energy frequently causes the surface of our star to erupt. The core, or center of the sun, is a mind-boggling 15 million degrees Celsius. That's 27 million degrees Fahrenheit. The photosphere is the layer of the sun that is the light we can see. The photosphere is only about 6,000 degrees Celsius, or 11,000 degrees Fahrenheit. The sun's outer atmosphere, called the corona, is made up of thin gases. The corona has temperatures of 1 to 2 million degrees. Even though this layer reaches out millions of kilometers from the sun, it can only be seen during a solar eclipse without special telescopes. The sun is constantly giving off streams of charged particles. These streams are called solar wind. These charged particles fly towards Earth all the time. But sometimes a storm on the sun can send huge amounts of particles towards our world. These strong waves of energy and radiation can cause all kinds of problems. You can think of it like the sun is sneezing, and sometimes the Earth catches those sneeze particles when it's headed in our direction. Ew. So how do we steer clear of these sun sneezes? Well, fortunately, Earth has a protective outer layer called the magnetosphere. The magnetosphere is the magnetic atmosphere that surrounds our planet and manages to keep away most of the harmful radiation coming from the sun all the time. That's why we're safe down here on the planet. One type of solar sneeze is called a solar flare. Like giant pools of gasoline igniting, solar flares explode like bright flashes. Some flares extend upward nearly 100,000 kilometers into the corona. They are very powerful explosions. Another type of sneeze happens when the sun's corona splits open and spews out as much as 20 billion tons of material into space. Wow, good thing Earth has a big hanky. These explosions are known as coronal mass ejections, or CMEs. CMEs are so powerful you can call them the flu of space weather. Fortunately for us, very few CMEs are aimed at Earth. CMEs and flares can throw large amounts of highly energetic charged particles out into space. Sometimes these very energetic particles race towards Earth, reaching the planet within 30 minutes. You want to know what happens when the Earth's magnetosphere, or handkerchief, doesn't catch all the sneeze particles? Sometimes these space storms cause a change in the Earth's magnetic tail on the side of the Earth facing away from the sun. These changes create auroras in the polar regions. Auroras are beautifully colored light displays that happen at night and usually near the Earth's poles. Even though these storms don't happen often, it's still important to keep an eye on our friendly neighborhood star. NASA scientist Nikki Fox studies storms from the sun. She's a solar scientist.
If the sun is very active, it can be having a lot of solar flares, a lot of bright flashes, can be sending out a lot of energetic particles. We can even have big solar storms, and they are going to impact the Earth. So we want to be able to predict, in the same way that you would protect yourself with an umbrella, we want to be able to provide some protection for the spacecraft and for our astronauts up in space.
But remember, the Earth is protected from the majority of space weather because of its large protective magnetic field that extends into space. So now you can see why it's so important to keep an eye on the relationship our world has with our local star, the sun. Zoom tight.
Now that we've learned about the relationship between the sun and our Earth, let's talk a little bit more about the forms of energy that we get from the sun. The sun is a big ball of energy that constantly sends heat and visible light toward Earth. One form of energy the sun sends to Earth is infrared radiation that we feel as heat. Heat energy keeps our planet warm and comfortable for living things. Another is visible light. Visible light allows for our eyes to see objects. The sun also sends energy towards Earth in the form of ultraviolet light, which is also referred to as UV. We can't see UV light with our eyes, but we can see and feel some of its effects, such as UV can fade the colors of paper and fabric, and UV can cause sunburns. If too much UV light hits your skin, it can damage your skin cells and make your skin very red and painful. If the ozone layer gets thinner, then we have less protection from UV light. Too much ultraviolet light can also cause cataracts and skin cancer. It can also damage plant DNA. Let's get to our activity, Make Handprint Art Using Ultraviolet Light. You can find the activity at the following website. In this activity, we will be using sunscreen, which contains chemicals that can reflect or absorb UV light. This activity will demonstrate our big idea that the sun provides two types of energy for the Earth. One, infrared radiation we feel as heat, and the other light. One that allows us to see, and the other ultraviolet light we call UV rays that we can't see, but do see its effects on our skin when we stay out in the sun too long without protection. You will need the following materials: construction paper, red or green works best. Sunscreen, a brand that is at least SPF 30 and doesn't contain metal oxides works best. Rocks or other small, heavy objects, and a sunny spot outside. Next, you will have to open the sunscreen and squirt a pea-sized amount onto your hand. Then rub the sunscreen all over the palms of your hands and the surfaces of your fingers. Don't rub it in so much that the sunscreen all absorbs into your skin. You should still barely see a thin layer of sunscreen on your hands. Place your hands firmly on the construction paper. Be sure to press down all of your fingers and the palms of your hands. Place a piece of construction paper outside in a sunny spot. Make sure that the spot you choose will have consistent light for 3 to 4 hours. Place a small rock on each corner of the sheet of paper. This will prevent the paper from blowing away in the wind. Leave the paper out in the sun for 3 to 4 hours. After the long wait is over, go outside and look at your paper. You should notice that the sun's UV rays have faded the color of the paper. However, the areas that were protected from UV rays by the sunscreen and the rocks still have the original bold color. If you want to learn more, why not try an experiment? Do this activity again, and this time use something you find around the house, like maybe hand lotion without sunscreen. I'm certain that you will get very interesting results. Let's review what we have learned and demonstrated with making handprint art using ultraviolet light. First, we learned that the sun is a big ball of energy that constantly sends heat and visible light toward Earth. One form of energy the sun sends to Earth is infrared radiation that we feel as heat. Another is visible light, which allows our eyes to see objects. The sun also sends energy toward Earth in the form of ultraviolet light, also referred to as UV. We can't see UV light with our eyes, but we can see and feel some of its effects, such as UV can fade the colors of the paper and fabric, and UV can cause sunburns. If too much UV light hits your skin, it can damage your skin cells and make your skin very red and painful.
Thanks for watching this NASA STEM EPDC Quick Bit. Don't forget to check out the description below for more information and links.